Okay, the 3 stone blocks have weights of 600, 150, and 500. Determine the smallest horizontal force that must be applied to block C in order to move this block. So we just want C to move. We don't care if A and B move. The static coefficient of static friction between the blocks is 0.3, and between the floor and each block is 0.5. So 0.5 here, here, and here, 0.3 here and here. So there's 2 options. The first option is the blocks all stick together and they all slide to the left. So we'll just call that all blocks slide. Now that's a very simple analysis. We'll do that one first. The second method is A stays still, B pops up, and C slides over, which required movement at this joint, movement at this joint, and movement at the floor. So we'll start with all blocks slide. So then it's just the total weight times mu, 0.5, equals P. Because in that case the free body diagram is just 3 blocks stuck together, friction on the bottom, P on the side, normal up. So, and the normal will then be equal to the weight. So the weight total is 1250 times 0.5 equals P, and that total is 625. Okay, then let's look at block B lifts. A does not move. Okay. So we'll draw this free body diagram of C. That's better. I'm out of lead. We'll use this pencil. Okay, so we got P on the end. We got a normal here. We got a force of friction. We got 500 down. We have a normal here. Call that NC. And we got as this block lifts up, it's going to be pushing, this block will be pushing normal, so the slide is up, so the friction here is up, so that's 0.3 NC. This one is 0.5 N. That's it for that block. Then drawing this block, a little wedge piece B, we have friction down, which is 0.3 NC. We got a normal C. We got $150 down, normal A, and friction down, which is 0.3 normal A, and that's the free body diagram for that one. Let's write the equations for this block first. So we'll sum the forces in the y. So we got 0.3 in A down, minus 150. This angle here is 45 degrees, so we got negative 0.3n times 0.707, right? The sine and cosine of 45. And then NC is going up there, so plus NC times 0.707. So that equals 0. Cleaning that up a little bit, we get negative 0.3 in A minus 150 plus 0.495 in C equals 0. And summing the forces in the X. In the X we have NA over, we got the components of these two. So NA minus 0.707 NC minus 0.707, 0.3 N C, NC also, equals 0. So NA, moving those to the other side and combining them, gives us 0.919 NC. And we'll put this into right there. And we get negative 0.3, 0.919 NC minus 150 plus 0.495 NC equals 0. And solving that for NC equals 684 for NC. So let's sum the forces in the X direction here. So in the X direction we have P, negative P. So this is block C. This was block B. So we have negative P. We have positive 0.707, again 45 degree angle, in C, 0.5 in, and we have plus 0.3 NC times 0.707. Okay, putting this value into there and there. We get negative P plus 0.707 plus 0.3 times 0.707, 0.919 in C plus 0.5 N equals 0. So let's sum the forces in the Y direction to find N. Oh wait, I didn't want to do that. I want to find out whether block A moves. That's my goal. So let's hold off on this, and let's solve for block A. So NA is equal to 0.919 times 684. Okay, and that is equal to 629. So that's NA. Now the question is, on block A here, we got NA pushing this way. Is the force of friction there great enough to resist that and keep it from sliding? So the force of friction at block A, block A right there, is going to be equal to 0.5 times the mass of block A, which is 600, which is 300. So the block A can only resist 300, but to get to block B to go up, we need 660, so that's too much, and block A will slide before block B lifts. Therefore, the failure mechanism is all block slide at 625.